Hello, welcome to this lesson of Mastering Java, and what we're going to do here is talk about additional floating point data types. We've talked about the double quite extensively, and that's for a good reason. It's because the double floating point representation is really the standard, it's the default, it's the most common variable type you'll use for floating point numbers in Java. And what do we mean by floating point anyway? It just means anytime you have a number or a variable that's going to contain a number that has a decimal point. So for instance, 1.5 is a floating point number. 32.89 is a floating point number. Negative 0.62 is a floating point number. So integers are whole numbers. Floating point data points or data types are numbers that have a decimal point. Okay. Now here's the deal. The typical standard floating point representation in Java is 64 bits. So this 64 bits means you have a whole lot of decimal places after the decimal point where you can have numbers. So you basically can have longer numbers with more digits after the decimal point. But Java also provides what we call float. Float is a data type. It's a floating point number, but it only has 32 bits. 10, 15 years ago, this would have been very standard for your floating point numbers to have 32-bit representation, but now computers are so powerful and we have so much memory that the standard is what we call double. So back in the day, your normal float would be 32 bits, and your extended float with more digits would be what we call double. Double meaning double precision. But it's now flipped around in Java where the typical standard is this one, and if you need a smaller number for some reason, or numbers that don't have that many digits behind the decimal point, you would use this one here. Again, I'll say again, just like with integers, 99.99% of the time you're just going to use double, just like we've been doing all along. But in this lesson, we'll introduce the other one just to show you. So as we said before, double is the standard default data type that we use in Java. So you can say double num1, and you can make it 74.33 if you want, and make that assignment. Most of the time you'll be declaring double variables with the keyword double, which is what we've been doing in all the programs up to this point. Now, occasionally, if you're writing a program that's operating on an embedded device with less memory, then you might want to declare your floating point numbers like this and save a little bit of memory, because every single variable will have less bits assigned to it than if they were all doubles. So if for some reason you wanted to do that, you would declare a float with the float keyword. Notice that it turns purple as well. And I can say this is num2, and I can say this is 76.3 or 54, something like this. And notice what happens when this goes on. When I declare a float, and then I give it a variable name, and then I put what I think is a very common standard number that I might put here, it's underlined in red. When I hover over it, it says type mismatch, cannot convert from double to float. And this kind of stuff infuriates new people that are new to programming. We've also talked about it a lot in the last couple sections. We talked about different data types with integers. What's going on here is anytime you type a decimal number, this is called a literal when we type the number in just like this. When we type this literal here, Java assumes it's double because, as I said, double is the standard floating point data type that we have. So it assumes it's double. And then whenever we take this and we put it into a floating point number, Java throws up a red flag here because here's the deal. This double precision number is 64 bits wide. That's a whole lot of space for a lot of precision. And here we're trying to tell it to stuff that number into a floating point, which is only 32 bits. So if you really do want to store this number in 32 bits, then it's possible, especially if I had a very large number like this, it's possible if I tried to do this storing that I would truncate a lot of data, I would truncate a lot of decimal points because I'm only storing it in 32 bits. So it's giving me that red flag, and it's telling me I can't convert from double to float. What it really is trying to say is I can't do this conversion without losing some digits behind your decimal point. So let me show you. If you really are going to use floating point numbers of type float, then what you do is very similar to the integers. You put an F at the end of it. And that tells Java, don't treat this as a double, treat it as a float. It tells Java, yes, I understand. I want to store this in this float, and I don't want you to treat this as a double, so there's no problems converting it. I just want you to store it in a 32-bit wide number. So effectively what's happening is this number is being treated as 32 bits, which is plenty big enough to hold these 4 digits in a decimal point, and we're putting it in the number there. So if I want to do system.out.print line, something like this, then I can print the number that we have here, which is num2, like this, and I can hit save, and I can run this. And notice what happens. 76.53 is what gets printed on the screen. Now let me show you something interesting. Let me go ahead and put a whole lot more digits in here. Let's say like this many digits. All right. I'm telling Java, here's the digit I have. Now, we don't even need that many digits. Maybe like this many. Here's the number I have, 76.538987908, and so on like this. So this takes a lot of bits to represent all this information. But I'm telling it to treat it as a floating point number. Let's see what happens. Let's hit run. Notice what happens. Java only gives me back 76.53988. In other words, what was stored in this variable num2 was a 32-bit representation of this huge number. So because I forced it in there, I have to give up something, and I'm giving up digits behind the decimal point. That's what your limitation is. Basically, this is going to be how many digits you're going to be able to store in floating point numbers that are of type float. Doubles can hold a whole lot more digits there. So just kind of keep that in mind. The bottom line is if you're going to use floats, you need to put that F at the end to avoid any problems. And so, if you keep it small enough, like 76.5398, it's not a problem. But if you have very large numbers after the decimal, you're going to run into problems. So let me take this off from now, and let's go ahead and do a calculation. One of the reasons why double is the default floating point type in Java is because all of the math functions in the math class that you have available, they all take double numbers for inputs, arguments, and they return double precision numbers for answer. So for instance, let me show you something. Let's create another variable. We're going to call it answer, like this. Okay? And I'm going to say answer is equal to, and I want to use a mathematical function. Watch this. Math, I'm going to type it with a capital M, and I'm going to put a period. And when I put a period like that, then this dialog pops up, and it's telling me that of the math class, right, these are the available methods. And you can see tons of methods here. You have absolute value, inverse cosine, you have cosine down here, and you start scrolling down this list. You have sine, tangents down here, convert from degrees to radians. I'll do more videos in the future about showing you how to use a lot of these things. Here's absolute value. So as I look through this class here, this math class, I'm going down to the S, and I see SQRT. That's the square root of a number that's double A. So that means the argument needs to be a double, and it's going to return a double. So I'm going to click that, or I could just type it if I want. I could double click, and it's telling me here's the square root, and I'm going to type in whatever my number is right here. And so for me, let me type in num1 because that's the variable I've already assigned. I'll put a semicolon at the end there. So notice the way this is written. It looks just like system.out.println, right? So you have a general class. In this case, it's the math class. The dot comes, and then this is a method that is a member of the math class, right? And so these are all done for you, and you don't have to really reinvent the wheel all the time. You're taking the square root of this number. The answer is going to give you a double precision floating point answer, and I'm going to store it in this variable, which I've already created, called answer. And so if I wanted to print the answer out, like this, then I could say let me do it like this, the square root of, and I could put num1 is answer, like this. All right, so let's go ahead and hit this guy, see if we ran into any errors along the way. The square root of 74.33 is 8.62, blah, blah, blah. Look at all the nice precision that I have after the decimal point because it's taking arguments in and it's returning an argument. We're going to get in a lot more later into methods and creating your own methods, but here's a great example of a method that you're calling from within the Java standard class libraries. The math class contains a method called square root. They've already done the heavy work for you so that it's doing the square root, and what it's returning is it's returning a number, which is also a double that's being stored into answer, and then that's what I'm printed on the screen. So when you have a minute, you might want to go type math dot and then start looking at a lot of these things and just kind of become comfortable. I'll do a lesson in the future to show you some of these things, but there are lots of things that you might have use for right here inside of the standard math library from within Java. So now that you understand a little bit about the difference between doubles and the difference between floats, the one thing I want you to take away from this lesson is that 99.9% of the time you're going to declare everything with a decimal point as a double, and the standard functions are going to work fine with that. All right. If you have to declare something as a float because you're trying to save on memory, then you need to put that F at the end to tell it to treat it as a floating point declaration and a floating point initialization of that variable. So go off to the example there and try to take a look at that. You get to use another function of the math library from within that example. So go read that example, do that yourself, and then take a look at my solution. And as we work forward, you'll build your skills step by step.